Yaskawa. This video shows how to configure and test Yaskawa's SigmaLogic servo for basic operation with an Allen Bradley PLC. Here's a quick preview. After preparing the hardware, configure the LogicWorks project, send the data, and reboot. A quick test to spin the motor and the system is ready to be programmed. This is the first video in the Quickstart series. The system for this example consists of a ball screw actuator driven by the SigmaLogic, an Allen Bradley Compact Logix PLC, and a PC with both LogicWorks and Ars Logix 5000 software. Everything talks through an Ethernet switch. To prepare the SigmaLogic hardware, install and wire the amplifier and servo motor according to the Sigma 5 option user manual. It is also important to install the battery and battery clip as described in the SigmaLogic user manual. Be sure to follow the SRAM initialization procedure. This consists of a one-time power-up with the init dip switch on. The SigmaLogic Quickstart guide outlines these details as well. Connect the Ethernet cable to the top port labeled Cn11a. It's important to know the IP address of each device in the system. The default IP address of port Cn11a is 192.168.1.1. Under network connections, the Ethernet port of my PC has been set to 192.168.1.50. It's important that the devices are on the same subnet, which in this example is .1. Verify that the config switch is in the on position and all other switches in the off position. Then power up the unit. After about 30 seconds, the ready light will go on. The alarm light may also turn on, but this is okay for now. Now configure the servo in LogicWorks. LogicWorks is a free download from yaskawa.com/SigmaLogic. Start a new LogicWorks project. A new project contains a usable default configuration. As best practice before connecting, under File, save your project. I'll call it config_servo01. Point the project to the IP address of the SigmaLogic, in this case 192.168.1.1, and a quick ping test shows we have communication. Then click Connect, and system information appears at the bottom. You can click the Getting Started link to launch the help for more details and for troubleshooting. Now, under Configure, the IP address and subnet mask for each port can be changed. I will leave the default. However, the default gateway must not remain at 0. Set it to match the IP address of port A. In this example, 192.168.1.1. Click Update Gateway and choose Reboot Later. The next reboot will apply this change. In Units, configure the load type, transmission, and load. For a 10mm lead ball screw with no gearing, load type is linear with unit of millimeters. The transmission will be left at 1 motor input rev for every load output rev. And the feed constant is 10 mm per rev of the load shaft. Examples for load and transmission are explained in the links. Under Options, a number of basic servo features can be configured. The actuator in this example does use hardware overtravel sensors, so I'll check the box. Unused options can be left at default. And you can click the I for information about each option. The external encoder page will also be left at default. File, Save, and the configuration is complete. To send the configuration into the SigmaLogic, go back to Connection, Send, and Send to SigmaLogic Axis. Clicking Send will overwrite any previous configuration. When complete, confirm the reboot. Be careful because rebooting stops motion in progress. Wait for the Ready and Run light in the front panel to turn on and stay on, and connect again. Now under Test Run is Motor Test. An alarm is likely to be indicated, so go to Monitor, Alarms, and Reset Active Alarms. Back in Test Run, confirm that main power is on, but not e-stop or either of the overtravels. Then enable test mode and confirm. For this system, I'll set acceleration to 1000 millimeters per second squared, and the same for deceleration, and a safe speed of 10 millimeters per second. Enable the servo, jog forward, jog reverse, and the monitors below confirm the motion. An easy way to verify the units is to set the motor position to 0 and then give a target position such as 10 millimeters. Hit Go to visually confirm the distance moved. Motor Test is also a good place to confirm operation of the overtravels. Hit the forward overtravel and be sure it stops. And then the negative overtravel also. At this point, everything seems to be working at the servo end, and so the next step is to configure the PLC to connect to the servo over Ethernet IP. So check out the next video, Quickstart Connect. Thanks for watching this video, and remember yaskawa.com/SigmaLogic for videos, documents, software, firmware, AOIs, and more.